Good morning. This is Cody Henriksen, and today we're going to be taking a look at doing Java recursion in the Fibonacci sequence. Just a quick overview of what we're going to be working on. We're going to take a look at the actual project itself. Some of the methods we're using, we're going to do a Stack Overflow demo so we can actually see the results of what a Stack Overflow looks like inside code. We're going to demonstrate the Fibonacci calculation using a recursive solution using ints, as well as a math-based solution, and has also introduced the concept of memoization. And we're going to change that and update support for long so we can see how we can get a lot bigger of a value at that, doing both the recursive and the math using the long approach as well. So we can see the growth rate that we see of the Fibonacci sequence. So we can see what happens with that. And that's what we're going to be taking a look at today using Eclipse. So if we go ahead and we'll switch over to that right now. Here we are inside the Eclipse project. As you can see right here, I have my code inside my recur controller file. So recurcontroller.java, and that's what we're going to be working with. We have a couple data members in here. I have a pop-up class, which is just a wrapper I use so I can use a JOption pane, but in a more object-oriented way. And so it's called view. And I have an int array called memoization for the memoization structure. We're going to go ahead and, as you can see right here, we have a bunch of methods we're going to be accessing as well as our constructor. And for the ones we're going to be working with to start off with, we have our stackOverflow method, our Fibonacci method, our mathfib, our fibmemo, the validate int and validate long methods, and of course our constructor that are going to go along with that. And we're going to start off by taking a look at the validate int and validate long methods, and we're going to go through and actually go to stuff that we're working on from there. So the validate int, validate long methods are just ways to validate user input because we can't guarantee the user is going to type in the right kind of value when we're doing a user-based program. And I want to make this so we can have user input for demonstrating what the values would be inside the project. And so we just take a string parameter, we set a Boolean variable is valid to be false, and we then use the try-catch structure. So we try and use a integer.parseInt, passing it that string value. We normally notice that we are not actually saving the results of that. We're just seeing if it actually executes. If it does execute, great, we'll set as valid to be true. If, however, it throws a number format exception, aka you can't turn that text into a number, we'll catch the exception and just have a pop-up display saying, hey, try this again. That way our code will not crash when we try and do stuff. The validate long method works in almost the exact same way, but instead of integer.parseInt, we have long.parseLong. Same basic structure, same approach to that, just again, so we can validate our user input. And those methods are there so we can have this be a user-based program as well as simply just execute the information we have inside there. Let's go ahead and take a look at the constructor first. Inside the constructor, as you can see, I'm initializing my data members that go along with this project. The memoization is a new int array of size 40, and I initialize the first two spots, 0 and 1, to be the base case values of 1. And this .view is a new pop-up class, so we can have instance to our pop-up class. We then have our start method, which is called inside the runner in the public static void main. And so I'm going to do just a little pop-up message and call the fibWork thing. And then we'll move in to the fibWork. And the fibWork is going to call our information on Stack Overflow, the Fibonacci, the mathfib, the fibmemo, and use those methods to make that happen. So that's we're going to go ahead and take a look at that right now, and we'll go from there. As you can see right here, we have our fibWork method. In the fibWork method, the first thing we're going to do is we're going to demonstrate what the Stack Overflow is, and we're going to then use some user validation, making sure something works properly so we can actually get a number we can test within the actual validation structure. And then we're going to go ahead and display the message of the results of that. We will then do a math example as well as the memo example, that same exact number we use for the solution. And then we're going to demonstrate how we can use that same thing right there. Then we'll stretch that process back out and do with longs as well. So we'll see that process happen. So let's go ahead and start the program right now and go from there. So we have a recursion project. We have a cute little pop-up with my little OctoKitty friend here talking about recursion. Go ahead and press OK. And it's going to cause a Stack Overflow. So we're going to go to Stack Overflow. We're going to pass it the parameter of 2. So before we do so, let's go ahead and scroll down to that and take a look at the Stack Overflow method. We'll move this over here so we can see this at the same time. And so my Stack Overflow method is an example of what not to do inside a recursive solution. So we have our Stack Overflow method. It takes an int parameter. And as you can see right here, if my parameter is greater than 0, I'm going to call the exact same method, Stack Overflow, which is what recursion is. I'm going to pass it a parameter that's going to make it never pass the base case, parameter plus 1. And adding 1, the only time this is going to ever possibly pass the base case is if I wrap around my int, have integer overflow, which is going to take forever, which means it's going to cause so much joy. Let's take a look at that. So go ahead and press OK. And, crash, burn. Look at that. I have all these lovely errors all the way down. You can see that it's scrolling because it doesn't take a lot of execution bar to do it. So we scroll, we scroll, we scroll. And here we have right here that we have our exception thread main. We have a java.lang.stackoverflow error. So we have a Stack Overflow. You can see that it called that same line over and over and over and over and over and over and over. And it overflowed the stack of calls that exist inside our JVM. And with that overflowed stack, nothing can happen. So we've crashed our program. And so that's what we want to avoid happening. So we'll go ahead and we'll turn that off, close the screen down. And we're going to skip past these 2 lines because we never want to do that again. So I'll just comment them out. And we'll go ahead and switch the actual recursive structure so we can see what's going to happen with that. So we can go to command run. start that back up again. And so we're going to introduce recursion. And so we have our recursion project. We're going to type in a whole number. And so I'm going to type in a whole number just to start making sure this works. And we'll type in something that's wrong. So some keyboard mashing, and boom, not an int, try again. And if I keep doing this again, it keeps doing that because I have that lovely while loop right here that as long as I give an invalid response, it's going to keep asking me to do this over and over again. I'm trying to use some robust programming to make sure that my application doesn't crash because of a poor choice by a user, in this case me. So my program doesn't crash just because I, the user, did something wrong. Now let's go ahead and give it a correct value, and we'll give it 10. So it's a number only. It's going to say OK. We're going to get past that. And then we're going to go into this point right here, and we'll switch to this. We'll say int example is integer.parseInt. So it's going to take that number 10, turn it from a string, turn it to an example int. And then that result value is going to be assigned default 0. I always initialize my variables, even local ones, with a good value. So no matter what, we have it automatically ready to go. And then it's going to ask us to look at the results of that Fibonacci number. And then it's going to calculate that inside Fibonacci, so we'll go look at that point and see where we're going. So we'll say OK. Now let's look at the results of the Fibonacci method. And so we're going to send example to Fibonacci. So let's scroll down to here. Close that one out. And so again, we have our Fibonacci sequence generation right here. So if the number is equal to 0 or the number is equal to 1, again, remember when we're doing Java evaluation, we have to have a complete logical expression in between each of the logical operators. So I can't say number equals 0 or equals 1. I have to have a complete sequence right here. In this case, number equals 0 or number equals 1. And again, also remember you have to use the double equal sign, not just 1, but 2, so you can do evaluation. If the base case is met, we return 1, so we've reached that base case of the Fibonacci sequence. Otherwise, we'll return Fibonacci of number minus 2 plus the Fibonacci of number minus 1. So we can repeat that process over and over, recursively calling itself until it meets the base case for all the values. So the 10th number of the Fibonacci sequence is 89. So it calculated that value for us properly. Wonderful stuff. So we have that right here. So view.displayMessage is the 10th number of that. So we have that value right there. Our next example, we're going to use the math Fibonacci sequence, and I'm going to use example plus 1. And the reason we're going to use example plus 1 is because those math people, bizarrely, they don't start counting at 0 like we do. I know, it's crazy. We start counting at 0, they start counting at 1. I know, but it's cool. We're all good. So let's go ahead and take a look at the math solution for this. The math solution is a lot more efficient. It's a better way of calculating the results for Fibonacci. It's a little bit longer though. And so what we have right here is we're using the math Fibonacci sequence. It still takes an int parameter. Int result, still a nice little number right here. I'm going to use typecasting. So I have a cast as an int. And then I'm going to get the result from math.pow 1.0 plus math.the square root of 5 raised to number, that parameter we send right there. And we're going to subtract that from math.pow of 1.0 minus math.square root of 5, and all of that raised to the same power. We then divide that entire numerator by math.pow of 2 to that number times the square root of 5. This is a lovely mathematical solution that works for every single integer for all values of the Fibonacci sequence. It's a great thing. Really quick and fast, and it's a lot more efficient to use our time to do it this way. So we'll go ahead and we'll continue on with our project and do it the math solution. And 89 is the same value using algebra calculation. Woohoo, it works. Hooray, hooray. And then we're going to take a look at the fib-memo example. So let's go take a look at the memo method right here. And so the Fibonacci memoization structure, it's, hey, I want to use recursion, but I want to make it more efficient. And so redoing calls over and over and over, if you look at the tree of calls for the Fibonacci sequence, and when my other videos are inside your textbook or talking with your teacher, you notice that exponential growth and the calls over here are repeating the same calls over here. And we don't want to waste time. The computer shouldn't waste all that work. So instead of wasting the work, we're going to memorize the work or memoize the work. And so if memoization sub number is not equal to 0, because when you initialize an array, all default values are, that's right, 0, then we'll return that default value. Otherwise, we're going to say return memoization of that number will be the value that's at fib-memo of number minus 2 plus the fib-memo of number minus 1. So we can grab that value and repeat that process, go back and assign values again as needed, and then return that number at that spot. So we can assign the values in there and then return it and go on. So it's a great feature for that. So we'll go ahead and run back up and switch back to the program. And at 89, correct. We worked again. So we have using that same one. So this is memoization sub 10. So we have right here using the fib memo example, we have view.displayMessage, and we're going to say this is the 10th spot, a memoization example. It's also 89. So it correctly calculates the memoization example as well using that same approach. So we can store that right there. So we've demonstrated now a quick way of going over the how to do memoization, how to do the math solution, how to do the regular Fibonacci recursive solution on that. We've demonstrated that with using an int. An int is a wonderful tool. It has plus or minus 2 billion worth of storage. We can get some really big numbers. However, the Fibonacci sequence grows really, really fast. So when we talk about Fibonacci sequence, we're going to try this as a larger number. And let's get this so we don't show that Java runtime error that doesn't matter for anything. So we're trying a large number. We'll try 50. Now, that's not really a big number for us as a human, but when we're talking the Fibonacci sequence, the 50th number in that value, we have to wait. We have to wait. We have to wait. And the reason we have to wait so long for this is because of the fact that we have that big, huge, redonkulous stack of calls that we just talked about. And so this is one of the reasons why recursion is not always the best solution. And in fact, in simple problems like the Fibonacci sequence, it's the wrong solution. So let's go ahead and change this to use a long value because we can have it so we can do a little bit with a longer number. And so that's what we're going to use validate long instead. And we're going to change this, instead of having an int type, we'll change this to be a long. And a long right here. And so that's going to be not a big change for that on there. And then for the math fib, we'll do the same approach. We'll change this to be a long and a long. That goes to be a long. And that goes to be a long. And if you haven't covered longs already, it's like an int, but a lot bigger. So not a lot of work we have to do to change that and make it happen, but we're going to see what happens with this. And so we're going to see a really big change in the growth rate. We also have to make sure we change the loop on here, not validate int, we're going to change this to be validate long. Making sure we properly ask the right question too. So we change the validate long, we change the long parameter, and so we'll type in 54. And we have a lot bigger than 2 billion because we're now, there's 445, there's 862,000, there is 583 million, and 139 billion. That's a little bit more than 2 billion. So that's just with 53. Okay, we do have to make a small change to our code to support a long on this. We also have to make a cast of the parameter because the array structure only takes ints as a parameter for its access point inside the array. Not a big deal, but we do have to make that happen. So we'll go ahead and make that store right here. So we'll go ahead and rerun this program. And we're going to type in a long of 65. And so we have that huge number with algebraic calculation. And then we can calculate that same value using the memoization factor, which is way faster than we saw. So we look at the methods we did for that. We demonstrated how to see a stack overflow. We learned how to do calculation with the recursive solution, a math solution, as well as a memoization. And we updated to support with that using recursive math as well as the... so we can do it with the long end for that calculation. We saw the fact it takes forever when we're using recursion when we do big numbers. And so again, just a quick review of those methods, just so we can see what we've done. So to do a long support, all we have to do is change the parameter type to be a long using the regular recursive solution. It doesn't make a lot of change to make that happen. It just has to return a long value. And that does have a support for bigger numbers, but the length of time it takes is still going to be forever. Using the math solution, updating it to long, doesn't make any change at all in the amount of speed because it's still really, really fast. We still just have to cast as long and build the result from there. And that works for any integer value, aka whole number, integer in the math land, long in the Java computer science land, no big deal right there. And then for the memoization, to update it for a long, all I had to do is we did have to have a cast on the value right here when we're going inside the array because the array parameter needs to be an int to support that value. We also covered how to validate user input using a validate method so we could have that happen. And I made just a pop-up wrapper class called that uses JOption pane and put pictures in that. You can take a look at that in another video. We'll have a reference to that as well on the channel. And then we just use that using a fibWork method right here so we can go through and demonstrate the different components of the Fibonacci sequence. So if you have any more questions, check with your teacher. Have a great day. We'll see you in the future. Thanks. Bye-bye.